A very good morning to my lecturer and classmates. My name is Tam Tae-in with matrix number F1008. So, allow me to introduce you to my team member first.
My name is Ani Gizan Zahari. I am from class DKM1B. My no metric is 20 DKM21 F1032.
My name is Francis Chai Solo. I'm from DKM1B, metric number 20 DKM21 F1062.
Hello, I'm Muhammad Akil Minozui Binotari. I'm from DKM1B. My metric number is 20 DKM21 F1086.
Well, today we're going to talk about vector and scalar in the architecture. First of all, let's go to the introduction part, vector and scalar. What is a vector? Vector is an object that has a both magnitude and the direction. We can picture a vector as a directed line segment whose length is the magnitude of the vector with an arrow that indicates the direction. So the direction of the vector is from its tail to its head. Well, for your extra information also, the tail symbolizes the origin of the vector. Well, don't forget that. In the vector, we can find many other formula in order to find the dot product, area, and the angle between the two vector, and so on. Well, ladies and gentlemen, let's go to the next slide. So in this slide, you can see that there are two vectors, A and B. In order to find the dot product, we need to multiply both magnitude of the vector A and B, then multiply by the cosine of the angle between them. Well, here you go. You can find the dot product. Well, if this is written in the component form, all you need to do is you need to multiply X component with Y component, and the result will be sent as the green highlighted. Ladies and gentlemen, theoretically, after you're done with the dot product, dot product is all about to measure how similar both vectors are. So, for example, safe to say is, let's say, when the length of the both vector are is 1, and when the angle between both vectors are 0, the dot product will equal to 1, positive 1. And when the angle is equal to 90 degrees, the dot product will be equal to 0. And as the vector B moves to the opposite direction of the vector A, the dot product will be equal to negative 1. Well, it's all about how similar both vectors are. So if you ever wonder where does we use this in the real life, so in the real life, the great example will be about solar panel. In this case, we can see that there are two vectors. One vector is a point outward of the solar panel, and the another one is point to the sun. So as the vector that point to the sun move closer to the another vector, and that the dot product will be positive 1, and that means more solar energy again. More solar energy are absorbed by the solar panel, right? Well, see, everything. The vector can be used in many ways. For example, video games. Right. Well, that's all from me. I will pass this to the Akil. Thank you.
Hi madam, I would like to talk about application of scalar and vector in today. First, roller coaster. Most of the motion in a roller coaster ride is a response to Earth's gravitational pull. When a train reaches at a peak point, then ride to the downhill, it gains enough speed for a gravitational pull. With the speed, it climbs to the next hill. This process occurs over and over until all the train energy have been lost to friction. the train would be able to keep running as long as no point on the track was higher than the first speed. Second one is boat crossing a river. When a boat crosses a river, there are two velocities work together, velocity of river and velocity of boat. The direction of boat changes with the respect of velocity of river. So, the boatman find an angle for crossing the river to reach the bank of river straightly. That's all for me, thank you.
Thank you. Now it's my turn to show you the mathematical solution for this vector and scalar in architecture. As you can see in these slides, there are a building which is a parallelogram shape. Then the question is find the area of the building from BCD. As the right side, you can see there are shape of parallelograms, which I already state BCD. And let's get started how we calculate. As you already see in these slides, there's already given OB equal to 2, 3, 1 and OC equal 4, -1, 0 and OD is 0, 2 and -1. The question is find the area of the building from BCD. So BCD, you need to make it different, like BC and CD. So BC equal to BO plus OC. There's no BO here, right? There's a OB. Then how you need to do it? You make a OB which is 2, 3, 1. You need to change the integer to BO is -2, -3 and -1. So continue. -2, -3 and -1 is plus 4, -1, 0 which is OC. And they are gonna equal to 2 -1s and 2, -4 and -1s. Then we continue to CD. There are CO here, there's now CO here. So we need to change the integer OC integers to CO, which is gonna be -4, 1 and 0. So plus OD, OD is 0, 2 and -1. The equal for this CO plus OD is -4, 3 and -1. So now the second step is you're gonna multiply it. Multiply BC and CD. You need to make it inside the columns IJK and 2, -4, -1, -4, 3 and -1s. And it's gonna be -4 multiply -1 and -1 multiply 3 and continue like the same. So the first I gonna be -4 multiply -1 is 4 and -1 multiply 3 is -3. Then J is 2 multiply -1 is -2 and -1 multiply -4 is 4. And K is 2 multiply 3 is 6 and -4 multiply -4 is equal to 16. After that, you need to equal it and it's gonna be 7i plus 6j minus 10k. Then you need to square root it. Inside the square root, you need to 7 power 2 plus 6 power 2 and plus -10 power 2. After you plus all the 7 power 2 plus 6 power 2 plus -power 2, you need to square root. Then the answer is 13.60 unit 2. Thank you. That's all for my solution part.
Good morning. My name is Anitizhan Zahari bin Abdullah. My metric number is 20 DKM 21 F1032. Okay, today I want to describe about the conclusion of vector and scalar in architecture. The conclusion of vector and scalar is used to find the area of parallelogram. Second point, vector and scalar can be used to find the area using only the coordinates. Third point, vector and scalar is useful in solving problems involving area of parallelogram and triangle. Okay, This is a Q&A session about vector and scale in architecture. How we want to solve this area of parallelogram of AO plus OB is we must input the unit of AO and OB in this column and minus it, and then do the next session such as BO plus OC to get the second answer of 5i, 2j and 3k. Next step, we must multiply AB of BC such as what we look at this slide, and then put the next answer into the square of root to get the unit square answer, and then we must multiply of 13.75 to 1/2 to get the last answer. Thank you.
Well, that's all from us. Thanks for listening. Thank you so much.